Hello, I thought I'd have a look at this maths challenge by Matt Parker. Now, Matt Parker has an awesome YouTube channel, Stand Up Maths, and he's been doing a few challenges. Now, this particular challenge is quite an interesting one. Here's the video for it, and I'll leave a link to it in the description, and it's well worth watching. Essentially, if you have the numbers 1 to 7 on the inside of this plate, or table, as this is to represent, if you have a distribution of cards around the outside, 1 to 7, but in whatever order, if you spin the table, you need to find the position with the maximum number of matches. So you can see that this one doesn't have any matches. However, you could spin it round so the 3 lined up to that 3 and so on. So the challenge is to find any permutations which have the least amount of matches, and in this case it's 1. So there's going to be some permutations where you can only ever have single matches. You can't have 2 cards lined up, because if we turned this round, so this 5 came all the way around to this 5, then the 4 would be lined up with this 4, so we'd have at least 2 matches there. So we need to somehow figure out what permutation of cards would allow there to be only 1 match. And he was kind of then saying, okay, what happens if you expand that? Then is it possible to do it with any combination or any amount of numbers? So if there's, say, 9 cards or 5 cards, then what's the least amount that you can have, and what are those permutations? So you have a look at this. Yes, there's most probably some really fancy maths behind it. However, I do Python. I do coding. So can we solve that with Python? Unsurprisingly, the answer is yes, but how can we actually achieve that? Well, anyone who was in one of my classes the A-level classes anyway, have been working on getting all permutations of a sequence. So this particular thing, if you give it ABC, then it would return ACB, BCA, BAC, CAB, and CBA. So that would get all the permutations. Now I was looking at that code which we've been doing today, looking at the video and thinking, maybe we can use that code which we've so arduously wrote and use it to somehow solve Matt's math challenge. And we'll have a quick look, see if we can figure out some ways that we could at least start the problem. So one of the first things which I see on this, sorry Matt for hiding your face like that, you've got the table and you're spinning the table. Now, just off the bat on this problem, it may be useful to have a function which spins the table. So we can write a function rotate table that will take the table. That table will just be a sequence of numbers, and then it will just do it as a comment, return the table rotated by 1. Now I'm not particularly concerned about which way it's rotated, as long as we're rotating it the same way all the time. So that should be fairly easy to do, just a function on its own. For example, if table was A, B, C, D, then we'd be expecting it to be B, C, D, A. So it's just rotating it around. Okay, what other functions would be good? Well, it would be good to know how many matches there are on the table. So can we do a function which does how many matches, and to get how many matches, not only do you need the table, you also need all the cards on the outside, which were the guests in this example. So let's have table guests. Now this will return the amount of matching table places to guests. Okay, now that looks like some useful tools for this solution so far. What else would we need? So building up on the how many matches are there, well, it might be useful to know how many matches are there in all permutations for a specific set. So in this particular one there's 0, but if you spin it there'll be 2. So where we're looking for the least amount, so the worst case scenario, it would be quite good to be able to rotate and match the table with the guests. So that would rotate the table n times and return the lowest matches. Is it the lowest matches? No, it's the highest matches, isn't it? It's the highest, so what's the best we can do just by spinning the table? What we'll want the lowest on is the distribution of guests. Okay, so that you can give it a table, which will presumably be 1, 2, 3, 4, 5, 6, 7, and all the guests, which will be in whatever order, and it will tell you what the best you can do just by rotating the table is. Okay, so now what might be an idea is actually generating all of the different permutations. If only we had a function that did that. Generating all the different permutations and then running that through that rotate and match. So what we need is to calculate, and that will take nothing. So this is where we're doing all the work. We're defining the table, generating all the permutations of guests, and finding the configuration of guests with the lowest match. Now, when I tried this, I did find multiple solutions. So you can either get it so it just says, hey, this is the lowest one, or you can get it so any of the ones which have the lowest are all printed. It's up to you. But that should be a starting point, and with that template you should be able to fairly easily create a program that will find the worst configuration of guests, which is what we're after. Because we've got all this in a nice function, what we can then do afterwards is change and put the number of guests. So then we can change how many guests we're getting. So we can run this program for multiple numbers of guests. When I first did it, I did it as a string because I was only really looking at it as 7. When you're looking at it expanding up, it's all good and well having it as a string, 1, 2, 3, 4, 5, 6, 7. That's awesome. The problem I found, however, was I got that working and thought, you know what, let's try it for more. And 8 worked fine. 9 worked fine. You may be stumbling across the problem here. If you do 10, then it will start doing different permutations and put that 1 in there. And all sorts of things like that. Not ideal and doesn't really work. So if you want to have a solution which is scalable, then you'll be wanting to have it in a list, and by that point, if it's in a list, then it doesn't really matter if it's an integer or a string, but I'll leave you to work that bit out yourself. So we've got our permutations code, then we can create those functions to solve this problem. Give it a go, see how you get on. Best of luck.